Hello everybody. For those of you who are already logged into our YouTube live event, please just bear with us for another minute. We'd like to allow a little more time for some other participants to join before we get started. And while you're waiting, if you haven't done so already, I'd like to invite you to please subscribe to our MACS Worldwide YouTube channel and help support the quality, professional, mobile AC information and training that you've come to expect from MACS through training programs like these. Well, hello everybody. Well, I'd like to welcome you all to MACS Section 609 Certification Test Prep Webinar. My name is Steve Shaber, and I'm the Manager of Service Training for MACS Worldwide, the Mobile Air Conditioning Society. Let's talk a little bit about how today's program is going to go. Some of you may have the printed book, but you can also go online and download a PDF copy of MACS Certification Training Manual. Just visit our website, www.maxw.org, and then click on Certification at the top of the page. So we're going to go through the rest of this slide presentation. And then ideally, after the presentation's over, that would be a good time to sit down with your paper and pencil test or to take your test online. Let's talk a little about the basic goals of the Technician Training and Certification Program. It's important to understand the environmental impact of venting refrigerant to the atmosphere. Venting refrigerant is illegal and punishable by large fines. You need to know the government's rules and regulations that are applicable to technicians and shops working on mobile air conditioning systems. This includes not only automotive and light truck repair shops, but also those who service medium and heavy-duty trucks, over-the-road highway trucks and tractor trailers, construction equipment such as backhoes, dozers, and excavators, along with agricultural equipment, and even some aircraft and helicopters which use belt-driven compressors and mobile AC refrigerants. You also need to know how to properly recover refrigerant. And along the way, we'll also review some best service practices that will help you keep your customers happy and maybe help you save some money and do your work more efficiently. To begin, we'll take a look at the historical context, which begins in the 1970s. Two scientists from the University of California came up with a theory which said that chlorine is making its way up to the top part of our atmosphere to an area called the stratosphere. Once there, it latches onto and destroys ozone molecules. So in our case, the chlorine was coming from R12, which was the mobile AC refrigerant used before 1995. Refrigerant 12 is a CFC, or a chlorofluorocarbon molecule, with chlorine being one of its main components. CFCs released from air conditioning leaks and service, aerosol spray cans, and even household refrigerators and bromine pesticides can make their way up to the stratosphere. Over time, this destruction of stratospheric ozone allows ultraviolet radiation from the sun to reach the surface of the Earth, where it can cause damage to plants, crops, animals, and also to people. Before the 1990s, it was common practice to just add refrigerant to leaking systems. It was also common practice to vent the entire refrigerant charge to the atmosphere if the system required any type of service which involved opening the refrigerant circuit. These practices were acceptable because refrigerant was relatively inexpensive and thought to be environmentally benign. But knowing what we do today about the role of CFC-12 in the degradation of the Earth's protective ozone layer and the potential of global warming, venting refrigerants is irresponsible and is not permitted. Under the Clean Air Act, this activity is illegal. And in other rulings, the EPA prohibits the venting of other refrigerants, including R134A, R1234YF, and other blend refrigerants used in mobile air conditioning systems. The ozone layer is located in the stratosphere between 10 and 30 miles above the Earth's surface. The ozone layer acts as a shield against harmful solar ultraviolet beta or UVB radiation. Ozone normally absorbs UVB. Decreasing the amount of stratospheric ozone results in higher levels of UVB reaching the Earth's surface. And this increase can be harmful to humans, animals, plants, and the environment as a whole. A concern identified under the Montreal Protocol was that a significant reduction in ozone in the upper atmosphere could result in long-term increases in skin cancer. Skin cancer is a serious problem, and cases of 3 distinct types have increased because of depletion of the ozone layer. Basal and squamous cell skin cancers are the 2 most common types. If detected early, these cancers are treatable. Even so, approximately 1% of cases result in death. Malignant melanoma is far less common, but substantially more harmful. 6 out of 7 skin cancer fatalities are due to melanoma. Cataracts cloud the lens of the eye, thus limiting vision. Although cataracts develop for a variety of reasons, scientific evidence supports the conclusion that increased exposure to UV radiation can increase the number of people suffering from cataracts. Damage to the immune system is another possible threat. Research suggests that exposure to UV radiation weakens the immune system's ability to fend off certain diseases. CFC's ozone degrading effect became more evident when the ozone hole was discovered over Antarctica in 1985. Recognizing the global nature of the problem, in 1987, in Montreal, Quebec, 46 nations signed a treaty called the Montreal Protocol, agreeing to phase out the production of ozone-depleting substances, including R12. Between the 1992 and 1995 model years, R134A replaced R12, and system design changes were required to assure that they performed equally as well. Some of these changes included new hose and seal materials compatible with R134A and the lubricants used with it. The new hoses and seal designs also reduced leakage. The most notable change, however, is increased condenser capacity and increased airflow to reduce system pressures at low-speed operation and city traffic conditions. In general, condenser performance for R134A systems increased approximately 30%. However, current environmental concerns are bringing about a switch to the use of more climate-friendly refrigerants due to global warming and climate change. So 3 years after the Montreal Protocol, our U.S. Congress passed the 1990 Clean Air Act amendments. So while the Montreal Protocol specifically regulates CFCs, Section 609 of the Clean Air Act is what gives EPA, or the Environmental Protection Agency, the authority it has to first establish mobile air conditioning service standards and requirements. It also prohibits the intentional release, which is any type of venting, of all mobile AC refrigerants. So that's where we've been, but what's happening now? You know, the whole environmental conversation has changed since the 1990s, and instead of the ozone hole, the new catchphrases are global warming and climate change. It's these environmental concerns that have brought the switch to more climate-friendly refrigerants. This chart shows the 5 most commonly used mobile AC refrigerants. So we'll start at the top and look at R12. Although CFC-12 has been phased out and is no longer being manufactured, it's still widely used in many classic vehicles. Not only does this refrigerant destroy the ozone layer, it also has a high GWP, or global warming potential. Using CO2, carbon dioxide, as a baseline global warming gas with a GWP of 1, comparatively, R12's GWP is 10,900. This means that R12 is 10,900 times more of a global warming gas than CO2, and as such, is that much more harmful to the environment. Moving on to R134A, the industry switched away from R12 in the 1990s in favor of R134A, which does not deplete the ozone layer. However, R134A is still a powerful greenhouse gas, which means that it helps to trap heat when released into the atmosphere. While its GWP is much lower than that of R12, it is still 1,430 times more powerful than CO2, which is why the industry is once again in transition. As new model vehicle platforms have been developed during the past few years, global automakers have been converting many of them over to use the new refrigerant R1234YF. It has a relatively low GWP of 4 and must still be recovered like other MACS refrigerants. It is also classified by ASHRAE as an A2L mildly flammable substance. We also have 2 other refrigerants listed here, and we'll first talk about R152A. So since the EU, the European Union, has set a GWP limit of 150, this allows the use of R152A as a mobile AC refrigerant. The US EPA has also allowed R152A, but with certain use conditions due to its flammability, which is listed as A2. It must be used in what's called an SLMAC, or a secondary loop mobile AC system, and while not currently in production, it is being developed by several companies. And at the bottom of the list, CO2, because we know it all so well, we breathe it out each day, carbon dioxide is used as the baseline to calculate GWP. But it can also be used as a refrigerant. When it is, we call it R744, and it is currently being developed in Europe and installed in a few vehicle models in Germany. An advantage to R744 is its really quick pull down times, which means it starts blowing cold air quickly. And it's a natural refrigerant with the lowest GWP. But these systems also run at between 5 and 10 times higher operating pressure than R134A. CO2 is also an asphyxiant, which means it displaces oxygen, and in high enough concentration can cause both immediate and significant health issues, such as unconsciousness, convulsions, or death. So what's actually going to happen? Well, in the end, industry is going to be the one who chooses. The US EPA does not require the use of any particular refrigerant. They don't require the use of YF. They don't require 152A or CO2 or any of the other alternatives on their list. They say that OEMs, the original equipment manufacturers, are allowed to use any refrigerant that EPA has listed as acceptable, as long as they meet the certain use conditions set by EPA. Now, EPA does try to nudge manufacturers to using more environmentally friendly refrigerants, and they do that by offering them CAFE credits towards their corporate average fuel economy if they switch to a refrigerant that has a lower GWP. And at this time, almost every OEM, with a few exceptions, is manufacturing some, if not most, or even all of their vehicles with R1234YF. Since the original Clean Air Act in 1990, we've had 21 new rules come out from EPA, the most recent one being September 2016. And for those of you who were around in the 90s, you probably remember the sales restriction that we had on R12, which basically was that technicians needed to have a 609 card or a MACS card so that they could walk into a local parts distributor and buy cylinders of R12. Well, the EPA never carried that restriction forward to include R134A, at least not until they passed this rule that took effect on January 1st of 2018. So since that date, if you want to buy R134A, or if you want to buy any other mobile AC refrigerants, you have to have a MACS card or a Section 609 card in order to go into a parts store and buy refrigerants. Now, there is an exemption for those small cans that are sold at the big box stores, but the rule says that those small cans now have to have a self-sealing valve. So prior to January 2018, the small cans had flat tops on them. So when you would connect your adapter and puncture the can, you basically had to use it right away, or else whatever refrigerant was in that can would eventually vent out to the atmosphere. But the inclusion of these self-sealing valves allows the can to be resealed if only some of the refrigerant is used. There's also another rule that allows R1234YF to be used in certain Class 2B and 3 medium-duty passenger vehicles, heavy-duty trucks, and some complete vans. And also, if any of you work in salvage yards, there's some record-keeping changes that are made for disposing of mobile air conditioning systems at the end of the vehicle's life. So how does EPA keep track of all these refrigerants? Well, they have a list, and it's called the SNAP list, or Significant New Alternatives Policy. One of the new mainstream refrigerants that's on that list is HFO 1234YF, which is listed as acceptable subject to use conditions, which means it may only be used in new vehicles with components specifically designed for it. Okay, so what does that mean? It means that no conversions or retrofits are allowed for any existing MVAC systems. So just for example, if you have a 2009 Ford that originally came with R134A, then you're not allowed to take that 134A out and put R1234YF in. Now, likewise, if you have a 2016 Chrysler product that came originally from the factory with YF, it's against the law to take that YF out and recharge that system with R134A. Now, some of these rules don't apply in the same way to heavy-duty trucks, refrigerated transports, some of your off-road vehicles like ag and farm equipment, or some construction equipment. So the bottom line is that HFO 1234YF may be used in any light vehicle with an air conditioning system designed to use it. All of these federal rules and regulations are available on EPA's website at www.epa.gov/MVAC, where you can also read the full text of the US Clean Air Act and Section 609. One of the first ways that technicians were introduced to these EPA regulations was through certification. And the rule says that any technician who works for consideration, which means you're being paid in some way, and you're opening the refrigerant circuit of a mobile AC system, then you must be certified by an approved agency such as MACS. Primarily, this certification is required so that you can purchase mobile AC refrigerants when you go into your parts supplier, but it's also required simply to work on mobile air conditioning systems. Section 609 of the Clean Air Act establishes standards specifically for the service of motor vehicle air conditioning. But our fellow technicians who work on commercial, industrial, and residential air conditioning, they work under Section 608. Under Section 608, the EPA has established 4 different types of certification for those technicians that service and repair appliances other than MVACs. Technicians who service and repair MVAC-like appliances, such as farm equipment and off-road vehicles, they can choose to be certified by either the Section 609 program or Section 608 Type 2. And while buses that use R12 are MVACs, other buses and vehicles that use R22 as the refrigerant are not classified as MVACs or MVAC-like appliances, but rather high-pressure equipment covered under Type 2 of the Section 608 program. Certification under Section 608 Type 2 is also required to service cargo refrigeration equipment. So the photo in this side shows a cab-over truck with both cabin AC for the driver and front passenger, as well as a refrigerated container or a reefer unit for the cargo box. A technician servicing this vehicle would need Section 609 certification to work on the cab AC system and would also need Section 608 certification to work on the reefer unit. Also, some aircraft fall under Section 609, such as helicopters and small airplanes that use less than 20 pounds of R134A and have gear or belt-driven compressors that cool the passenger compartment. So here's a question that I get all the time. What about those guys that are working on their own cars? Those guys in the parking lots we see on the weekends? What about them? Don't they have to be certified? Well, the way the rule's written, persons working on their own mobile air conditioning system are not covered under this rule and can add refrigerant without being certified. However, anyone found to intentionally release refrigerant into the atmosphere under any circumstance during the repair, maintenance, or service of mobile air conditioning systems can be fined. This applies to any mobile AC refrigerant, not just limited to R12 or 134A, but also R152A and R1234YF. EPA assesses penalties for violations on a case-by-case basis based on many factors outlined in EPA's penalty calculation policy. And since January 31st, 2018, the Clean Air Act maximum statutory daily penalty is $44,539. One of the first requirements to affect shops had to do with equipment. Before the 1990s, shops would simply vent refrigerant in order to depressurize the system to perform service and repairs. But new EPA regulations required shops to recover refrigerant, meaning they have to use approved and certified recovery recycling or recovery-only equipment. Today, however, most shops use what are known as RRR machines or RRR machines that can recover, recycle, evacuate, and recharge the system with one machine. To comply with Section 609 of the Clean Air Act, the equipment must be certified to SAE specifications, and to prevent cross-contamination, each machine must only be used with one designated refrigerant. EPA regulations require that certified HFC 134A recover recycling equipment must conform to the specifications listed in the appropriate standard. The equipment must have a label which states, "Design certified for compliance with SAE J2210 or J2788. R134A recovery machines manufactured prior to 2008 were required to meet SAE standard J2210. Since then, the new standard, J2788, has been required, which offers increased performance, recovers more of the refrigerant from the AC system, and provides greater charging accuracy. R1234YF recovery machines must meet SAE standard J2843, while J3030 provides for a combination R134A and R1234YF machine. One of the concerns EPA has about servicing different vehicles is possibly cross-contaminating refrigerants. So in order to help prevent that, there's regulations about the actual service fitting that's used on the vehicle and on the equipment. So for example, the older R12 systems, they used 3/8-inch fittings, like the picture on the left. But R134A machines and vehicles use what's called quick couple fittings, such as the picture in the middle. Now R1234YF also uses quick couples, but they're a different style and a different shape connector, so that the R1234YF connectors cannot be used on R134A and vice versa. There's also a rule that says that shutoff valves have to be located within 12 inches of the vehicle end of the hose. Now, most of your service adapters today have the shutoff valve located right directly at the connector itself. But according to the rule, it says it has to be within 12 inches. We also have record-keeping requirements, which basically say that we have to register our machines with EPA. The form to do this can be found on pages 57 and 58 in your training manual, and it's a pretty easy form to fill out. You just write down the name of the shop, the address, city, state, and zip, and your phone number, and whoever's responsible for the equipment, either the owner or the shop manager. Then you have to write down the year, make, model, and serial number of your machine, and you mail it into the appropriate EPA office, depending on where your shop is located. There's no charge to do this, and you only have to do it one time for one machine. But there's a lot of situations where it's just not practical to use a full-size charge cart to service an air conditioner. For example, if you provide on-the-road service for your customers, it's much easier to carry around recovery-only equipment so that you can recover the refrigerant out of the system before you perform any work. Now, before you reuse any of that refrigerant that you've recovered with a recovery-only machine, that refrigerant must be recycled or fully reclaimed. These machines simply remove the refrigerant from a system and they do not recycle it or clean it. So then you would either take the refrigerant back to your shop and run it through your full-size recycling machine, or there's a lot of companies that provide refrigerant tank swapping services where they will come in and pick up your recovered refrigerant and swap the tanks out for pre-recycled refrigerant. As for the appropriate refrigerant tanks, we have to use certain tanks for the transfer and storage of refrigerant. They have to be DOT approved, and they have to have markings on them that say either DOT 4BA or DOT 4BW. Now, this does not apply to those new cylinders of virgin refrigerant that you buy from the store. It only applies to the internal tanks inside your recovery machine or the portable tanks that you take with your recovery-only machine and go out to job sites with. And remember, when you're working with these tanks, make sure you keep them away from excessive heat. So that means direct sunlight. Don't leave them out in the sun in front of the shop. Make sure that you don't store them in low or confined spaces. And of course, keep them away from sparks or direct flames. And one of the most important safety comments I can make is to always, always, always wear your eye protection. When refrigerant's venting out of a leaking system, it can come out at close to negative 50 degrees Fahrenheit, which is cold enough to instantly freeze your eyeballs. So please always wear your eye protection and do not take a chance. Also, you want to avoid breathing refrigerant because when it's leaking out, it's usually going to be carrying some lubricant vapor or mist along with it. You also don't want to allow refrigerants to come into contact with open flames and high temperature surfaces. Also, considering that R1234YF is considered as an A2L mildly flammable refrigerant, which means that it can ignite under certain circumstances. Now, R134A we think of as non-flammable, but it can actually become combustible when it's mixed with air under pressure in a sealed environment. So we want to make sure everyone knows to do not use shop air to pressure test an R134A system. For some people, PEG oil can cause redness or itchiness on exposed skin, and wearing gloves can help. Also, PEG oil is hygroscopic, just like brake fluid, which means that it absorbs moisture, in some cases, directly from the surrounding air. So keep containers closed and clean to avoid contaminating your PAG oil supply. Also, always be careful to not overfill refrigerant tanks, particularly when using recovery-only machines. Most incorporate an in-tank sensor that helps protect against overpressurizing the tank, but some don't have that kind of device. Check with the equipment manufacturer's operating guide to learn exactly how to operate your machine and tank. Also, be sure not to leave refrigerant tanks out in the sun or in direct sunlight. Remember that as temperature increases, so does pressure. And if the temperature of a refrigerant tank rises, so does the pressure of the refrigerant inside the tank. If the temperature or pressure of the tank is allowed to get too high, it could cause a dangerous condition. Also, do not open the covers of your recovery machine or perform maintenance work on the machine while it's connected to electrical power. The increased performance specifications for evaporators are explained in SAE Standard J2842. It requires all evaporators for HFO 1234YF systems, both original equipment and replacement, to have a permanent marking, like a label, a stamp, or an etching, that indicates the refrigerant for which it was designed and that the evaporator design meets the strength requirements of SAE J2842. Because R1234YF is a mildly flammable refrigerant, there is a concern that if an evaporator were to develop a leak, refrigerant could possibly build up in the passenger cabin. Although manufacturers take precautions with system design, industry will use special, stronger evaporators with increased protection against bursting and that are more resistant to pinhole leakage. Also note that it is unsafe to attempt any shop repair on a leaking evaporator, and it should always be replaced with a correct new unit to maintain occupant safety. The use of a salvage or a used evaporator from another vehicle may be dangerous and is not recommended, although a refrigerant control device such as a TXV, a thermal expansion valve, or a block valve may be reused if it is serviceable. The same requirements apply to evaporators in CO2 R744 systems. Now that we've talked about some of the equipment, let's move on and talk about service. As a first step, and before you open the system, always perform a visual inspection to spot obvious problems. Also, those service port caps themselves are actually the primary seal for the service port. And contrary to popular belief, it's not actually the Schrader valve that's down inside the port. So you want to make sure that if the system is missing its caps, that you always replace them to minimize refrigerant loss. Multiple refrigerants, refrigerant blends, and even hydrocarbons may be present in a mobile AC system. A refrigerant identifier can help alert you to refrigerant contamination problems to prevent you from contaminating your service equipment and other AC systems you may service later with the contaminated refrigerant. The service industry and EPA strongly recommend but do not require the use of this equipment. You can also use an identifier to help confirm what type of refrigerant is in a container. The identifier should conform to the SAE standards to assure that the unit correctly identifies refrigerants. Keep in mind, however, that even the best identifier may not be capable of indicating all the possible combinations of chemicals that may be in an AC system or a storage tank. Keep in mind this specific distinction. While EPA does not require the use of a refrigerant identifier, all RRR machines designed for use with R1234YF will require refrigerant identification prior to recovery. SAE J2843 requires that all recovery, recycle, and recharge machines built for use with HFO 1234YF have either an integrated refrigerant identifier or be capable of receiving input from a non-integrated identifier with a USB port. Mixing of refrigerants or cross-contamination, even a very small quantity of one refrigerant mixed with another refrigerant, can cause system operating problems and poor system performance. If refrigerant is identified as being mixed or cross-contaminated, it should be recovered into a junk cylinder. When that cylinder is full, it should be sent off-site to an EPA-certified reclaimer for reclamation or destruction. Remember, it is always illegal to vent any mobile AC refrigerant, even if it is mixed or cross-contaminated. So we want to make sure that the refrigerant's pure. And some of the things we're concerned about is volatile impurities that can get mixed in, or refrigerants recovered from non-mobile sources causing contamination. So SAE has a couple standards for refrigerant purity, and they basically are looking for three things. They're looking for the presence of air, moisture, and oil. So the different standards list how much contamination is allowed for different amounts of recycled R12, R134A, and R1234YF. Now, it's not important for the test to know what those part per million numbers are, but it is important to remember that the contaminants that are being looked at are air, moisture, and oil. And now for some tips on achieving the most complete refrigerant recovery. The amount of refrigerant that you can recover from a system depends on how much is in the system, of course, but also depends on ambient temperature, the technique you use, and the performance of the recovery machine itself. Since the end of 2007, RRR machine manufacturers have been building equipment that meets SAE standard J2788, which offers the best recovery performance compared with earlier machine standards. These same performance requirements have also been carried forward to the YF machine standards J2843 and J3030. The accuracy requirement is that the machine can recover 95% of the refrigerant charge within 30 minutes and that it can charge a system with plus or minus a half an ounce of accuracy. To remove as much of the refrigerant as possible during the recovery process, systems equipped with orifice tubes and accumulators require more time than systems equipped with expansion valves and receiver dryers. This is mainly because of the design differences between accumulators and receiver dryers. Being larger than dryers, accumulators located in the low pressure side of the system hold more refrigerant and oil than receiver dryers do. When refrigerant is removed from the system, the lowering of pressure results in some of the system components becoming cooler. This component cooling effect makes complete refrigerant removal in a short period of time more difficult. During the recovery process, as the system is drawn into a vacuum and pressure in the accumulator is lowered, the accumulator becomes very cold, with external frost sometimes visible on the accumulator housing. This makes it even more difficult to extract remaining refrigerant from it. If liquid refrigerant has not been removed and the refrigerant lines are opened, as the accumulator warms, a sudden release of refrigerant and oil can occur. Heating the accumulator with a hairdryer or electric heating pad will raise the pressure in the accumulator and reduce the amount of time necessary for refrigerant removal. But a J2788 machine does a great job over 70 degrees Fahrenheit and is designed to avoid this long procedure. But if you can't get to the accumulator, if heating it is not feasible, then at least follow the engine preheating procedure that's on page 15 in the certification manual. Let's take a look at that right now. It's called the engine preheat for removal procedure, and it assumes that you've already done one pull with your recovery machine to try to recover the refrigerant from the system. So at this point, you're going to set the dashboard controls to have the fan or the blower motor all the way up on high. You're going to turn the temperature knob all the way to cold. You're going to have it set for outside air, not recirc or MACS. And the compressor is not going to be operating. You're also going to start the engine and run it at idle for 15 minutes and keep the hood open this whole time so that warm engine air can enter into the cowl vents. At this point, you're going to turn the recovery machine back on and perform the refrigerant out gas test. During recovery, after the system is in a vacuum, you'll pause the recovery machine for 5 minutes and you'll watch the low side gauge. If that needle rises from vacuum into pressure, that means that refrigerant is still in the system and further recovery is necessary. So you'll turn the recovery machine back on again, and you'll pull it back down into a vacuum, and then pause again for 5 more minutes. And if necessary, you may have to perform this procedure over and over again until the system can remain in a stable vacuum for 2 minutes. Now, many of your newer recovery machines, such as J2788 for R134A or J2843 for R1234YF, will automatically perform this outgassing test for you. And in fact, the next time you run your machine, if you want, you can watch the low side gauge and see all of this taking place. Now, this is different from the vacuum decay test, which is where you pull a vacuum down during evacuation, hopefully all the way down to 28 or 29 inches of vacuum, and then pause and look for a decay or a leak in that vacuum. That's not the same test, so don't confuse the two. After recovery is complete, you'll want to make sure you check the RRR machine's oil reservoir. That's how you can tell how much oil was removed from the system, because whatever amount was removed, you have to replace that same amount of oil with clean, fresh, new oil. And make sure that you dispose of the used oil in accordance with any federal, state, and local requirements. Some of your RRR machines will have that oil reservoir right on the outside or on the bottom of the machine. And the container itself will have little graduations on it that show how much oil was removed during recovery. Generally, you're going to see very little oil, if any at all, but it really depends on the system that you're working on. However, if a large amount of oil is removed, the system may likely have contained too much oil to begin with. And when it comes to the type of oil to refill the system with, always use the proper oil type and viscosity. R12 systems used mineral oil, and R134A systems use PAG oil. But the R1234YF systems use a special type of PAG oil that's not the same as R134A. So make sure you don't mix them up. Also, R1234YF, R744, or R152A and other blend refrigerants may each require different lubricants. So there really is no AC oil that fits all systems. It's important to make sure that recycled refrigerant does not contain air, which is a non-condensable gas, in excess of allowable amounts. If recycled refrigerant contains too much air, typically more than 2%, high system operating pressure will occur, and pressure-operated refrigerant controls will have a different control set point. This will result in loss of air conditioning performance and possible system damage. Before recharging, it's important to evacuate the system, or what we call pulling a deep vacuum. We do that to remove air and moisture from the system before recharge. Most of your vehicle manufacturers recommend evacuating a system for 30 to 45 minutes if it's a front-only or a single evaporator system, and between 45 minutes and 1 hour if it's a dual system with front and rear air and 2 evaporators. However, keep in mind that you may remove possibly no moisture during evacuation, depending on your equipment and operating conditions. So the only way to remove a significant amount of moisture is to replace the desiccant, which is found in either the receiver dryer or the accumulator. To reduce refrigerant emissions, newer mobile AC systems use less refrigerant. Because of this, today's newest systems are critical charge. A critical charge system is one that is substantially less tolerant to variations in charge. The only way to properly and accurately charge a mobile AC system is to recover the refrigerant charge, evacuate the system, and then add the correct amount of refrigerant by weight using an accurate scale. Pressure gauge readings cannot determine if the charge is correct. Undercharges can result in poor cooling and, even worse, poor lubricant circulation, which can lead to compressor failures. Overcharges can result in high operating pressures, which can also cause poor cooling performance and even component damage. During hot weather conditions, overcharged systems can experience system shutdown from the high side pressure control switch or sensor due to high system pressure. The AC system label will identify the vehicle, compressor, or AC system manufacturer's recommended lubricant, often by an OE part number or designation. However, the label may not list the lubricant's viscosity. You may need to consult another source, such as a parts catalog or service information, to obtain the lubricant's viscosity rating. Sometimes, after vehicles have left the assembly plant as a result of field operational issues, an OEM may decide to increase or decrease the refrigerant charge. But unfortunately, the charge is not always reflected on a vehicle's factory-installed AC information label. So you must check service bulletins to find this type of information. Also, some replacement condensers require a change in the system charge amount, so always check when replacing a condenser. A vehicle manufacturer may find out long after a vehicle hits the streets that they can get better AC performance by increasing or reducing the system's charge. Or there may have been a late change in a component that changes the charge specification, and that change was not made on the production line or on the vehicle's AC system label. So unless you have access to the latest service bulletins, you may not know about it. Also, some replacement condensers require a change in system charge spec, usually a reduction. Ask your aftermarket parts supplier for more information when installing a replacement condenser. When you have determined that an AC system has a low refrigerant charge, you need to find the leak or leaks in the system. Many newer systems contain less refrigerant than older ones. Therefore, adding too much or too little refrigerant can quickly cause problems. EPA does not specifically forbid topping off a mobile AC system. However, several states and local laws do prohibit adding refrigerant into a known leaking system. So make sure you check the specific laws at your work location. Let's look at some tools and techniques for finding leaks. Soap bubbles will only identify leaks that are in excess of 40 ounces per year, compared to the use of an SAE J1627, 2791, or 2913 leak detector, which can identify leaks with a rate of less than 1 ounce per year. The US EPA and MACS recommend that leaking systems should be repaired. Obviously, first you have to find the leak, and there's a new generation of electronic leak detectors designed to help you do that. Older leak detectors had to meet the SAE standard J1627, which were capable of identifying leakage rates of a ½ ounce per year at a distance of ¼ inch from the leak site. The improved SAE J2791 detectors for R134A and SAE J2913 detectors for R1234YF can identify a leak rate as low as 0.15 ounces per year. A full refrigerant charge is not required to use an electronic leak detector. However, there must be a minimum of 50 psi in the system, which requires only about 10 to 15% of the total refrigerant charge amount. It will still work even when there's as little as 15%, because that amount will still build enough system pressure up to around 50 psi. Follow the manufacturer's instructions for proper use. Ultraviolet fluorescent trace dye systems are a popular choice for technicians today in their efforts to hunt down elusive leaks. Not only are they an inexpensive and easy-to-learn method of locating leaks, they also have the advantage of giving the shop visual proof of a leak, which can turn into an interactive experience with the customer. Keep in mind, however, that not all vehicle OEMs recommend the use of UV dye in their systems, and in fact may consider dye to be a contaminant. Always check with the vehicle's service information and follow their recommended procedures. Remember too that dye mixes into the refrigerant oil and refrigerant carries the oil around inside the system. In order for dye to be effective, a full system refrigerant charge is required. Open vent flushing often will not remove debris from a system. Connecting flush equipment to the service ports, even with the valve cores removed, will not provide adequate system flushing and may not result in the removal of debris and other substances. Many system and component manufacturers also have reservations concerning the use of solvents to flush systems. The manufacturer's main area of concern is that some solvent may remain in the system even after a prolonged deep vacuum. This residual solvent can dilute the lubricant, which can lead to inadequate compressor lubrication and possible subsequent compressor failure. It can also affect the chemical stability of the refrigerant, seals, and hose materials. Your shop tools and equipment require maintenance if you want them to operate properly. Let's look at a few specifics. Recovery, recycling, and recharge equipment should be checked frequently to ensure that no leaks exist within the internal refrigerant flow circuits, as well as the external hoses and seals. Regular maintenance of your recovery, recycling, recharge machines should help to ensure that SAE standards for purity for recycled refrigerant are met. Recovery machine filters and dryers must be replaced in accordance with the machine manufacturer's recommendations. Check the equipment manual for the filter's location. And last but not least, according to an industry survey, half of the replacement coupled hose assemblies are field coupled instead of installing new replacement assemblies. If assembled improperly, these units are prone to leakage. Follow the manufacturer's procedures for tube and hose fit and crimping. In the picture shown here, a combination of the incorrect tube and hose fit and crimping technique have caused the tube to deform. Also, the assembly has been crimped, rotated, and recrimped, likely producing a leaking assembly. And that brings us to the close of MACS Section 609 webinar. I'd like to thank everybody for participating. And like I said in the beginning, if you feel prepared and if you're ready, now is the ideal time to go online and complete your test. Also, if you have any questions beyond what we've talked about today, any questions or comments about MACS or how you can join MACS as a member, please visit our website, www.maxw.org. The MACS website is a great resource for all kinds of AC training materials, and you can download the latest edition of our Section 609 Technician Training Manual or Action Magazine, the mobile air conditioning industry's journal of record. And for those of you who are MACS members with a username and password, you have access to our members only section, where you can find back issues of Action Magazine, several issues of our MACS service reports, many AC training class presentations from MACS annual training event and trade show from the last 3 years, which is a great resource not only for technicians and shop owners, but also for educators as well. Check it out to stay on top of all things mobile AC. And finally, I'd like to ask everyone, if you like MACS videos and want to see more, then please subscribe to our MACS Worldwide YouTube channel. Thanks again to everyone for joining us. My name is Steve Shaber, and we'll see you next time.